Today we have a question from the comments.
It's questions from the comments.
I won't ever do that again. Cool. So today's question from the comments is from Lone Wolf and pretty much reads, thank you for these types of videos. You're welcome. Literally learned a lot. Good to hear. I have a website I need to scrape, hunter.co/jobs. There are a million listings in this website and I just don't know how to scrape all the listings. So we're going to be using the request library, we're going to be using for loops, creating functions, and we're going to uncover the page's private API. I hope you watch all the way to the end and I hope you learn something new. Let's get into it. Okay, so we know the challenge at hand. Let's get down to business. So what we'll do is we'll start off by navigating to the URL. Let's run that again. And what we're seeing here is we are seeing the website load up. Not the fastest website, but that could be based on my location here in Melbourne, Australia. First thing I'm going to do is I'm going to keep an eye on the URL and I'm just going to scroll down the page and just see how it is acting. Now, first thing I'm noticing, which is probably a good sign, the URL is staying the same and there's more listings appearing, which tells me it's likely doing some sort of private API call in the back end. So let's click on a listing and see what happens. Click on a listing and we get the details. Okay, we do know there is a million sort of listings. We got that number here, so a million. It's a little bit, and the commenter wants them all. So let's see how we go doing that. So first thing we're gonna do is I'm gonna go ahead and F12 in Chrome and open up my network and then my XHR and fetch. And what this is going to do is this is going to reveal to us any network traffic that's occurring on this website as we're interacting with it. So as I scroll down, let's see if we can get it to generate another page. There we go, boom. This is exciting. So if you can see that there, we've got the request URL as app.hunter.co public search job post, and it's got a parameter here of page 3. Now this is good news for us so far because that tells us we can probably just change that to page 4 and get some more results back. Now let's have a look at what it's actually providing back to us. Ooh, okay. So looking at the preview, we do have a number of different things available. Hey, look at this. Results. Okay, this is looking really nice. Hold up. Oh, I'm getting a bit excited here. What have we got here? Created ads, employer, main photo, original photo, post date, roles tags, team photo. This is rich. Like this is a rich amount of data. So let's go ahead and create this request in Python. Now, one of the easiest and quickest ways to do that is to right click and copy as curl. Now, curl command will typically run in your terminal on a Mac or a Linux machine, and it will go off and fetch the results of this API call. What we'll be using is this website here, which basically takes a curl command and provides us the Python output. So what we'll do, let's go ahead and talk through what this bit of code does. So first of all, we're importing requests, which in my previous videos we've used extensively. It's a way for us to get information from the internet. Here we have the headers, series of key value pairs, and then we have the parameters as well, so the params. And then the final step is to go ahead and invoke the requests library. Now we are using a get. Typically use a get or a post, so we're just saying, hey, we need to get that information, and it's passing in the number 3 for page 3. So for just for testing, what we'll do is we'll shift enter and run that. It's going off now. It looks like it's taking a couple of seconds to run. That's finished running now. What we might do is give ourselves a bit more space. Now let's have a look. So we've got response. First thing I'm checking for is the response code. 200, A-OK, good to see. Anything to 4 or 500s is bad. Anything to 300s is a redirect. And 100s is 200 is good. Cool, so the next step is we did notice that there was JSON data available to us. So we go .json. And what we've now got is all of this really rich information, okay? And the good news is that is of a type. You look at the type of, this is actually a dictionary. So the cool thing is because we're using the .json method, which is part of our requests library, that's not coming back as plain text, that's coming back as a dictionary for us. It's already done the hard work to convert it into a dictionary. So now all we need to do is interrogate this data and start to get out some of the values. So to do that, what we'll do is we will create another variable. We'll just give it a name, something like JSON response. Okay, and we'll say JSON response is equal to response.json, shift enter on that, and now what we have available to us is this nice big dictionary. So the first thing I'd like to do is run ask what keys are available on that. So dot keys, we've got results, clusters, total count, parameter counts, employee count range, so on and so forth. Now we did notice before that there was results. So to go ahead and ask for those, we just say dot results. And straight away what you'll notice is it comes back with a list. Now a list is just a collection of things. In this case, it appears to be a collection of dictionaries. Now we know it's a list because it has square brackets, but if we weren't too sure, what we can do, Shift Enter, and that's a list. And we can also ask the length of the list. It's a length of 30, okay? So it appears that each page that we ask for gives us 30 responses. Now, from memory, it was just over 1 million. We'll get the exact number here. So this is the exact number of jobs, which appears to be over 1,045,000 divided by 30. Oops, divide by 30. So to get the entire website, we're looking at 34,000 requests, okay? And that is just getting the actual posts. We don't know how much detail of each post is available in this JSON query. Now, I've roughly calculated it's going to take 2 to 3 seconds per post. So times it maybe by on the upper end of that 3 seconds, okay? And this is now how many seconds it's going to take. Divide that by 60 to get us to minutes, and divide by 60 to get us to hours. Okay, so about 29 hours to scrape this website. So just to keep that in mind when we are looking at extracting all of this data. You may want to slow that down even further and run it across several days, if not a few short weeks. That way we're good internet citizens and we're not hitting that website with too many requests. Okay, so where to from here? So we now have our JSON response object, and we know that that is what have we got here? JSON response object, and we know if we go to results, that is a list, and each of those is an item on the page. So what we'll do is we'll say something as simple as for, and we'll call it listing in. Now remember, listing as always is a local variable unique to the for loop, okay? And we'll just go ahead and print the listing for now for testing, and we'll put a break in there just so we get one item back. Okay, so now that we have the listing item returned, we can see that it is a dictionary, okay, by the curly braces. As we're scrolling down, we've got a few different keys that we can have a look at here. We've got ID, employer. I'm going to scroll down here. It looks like we've got the entire description of the listing as well, which is really good information to have. What else do we have? We've got a whole bunch of emojis, okay. What else do we have? Let's have a look here. So keep that in screen. And that's kind of it. So let's go ahead and interrogate this data. So what we'll do is, first of all, now that we've got the listing, let's go ahead and print out its keys, okay? Your keys are made up of employer, offices, roles, skills, tags, created that, employee count. This is really rich. HTML description, and we also have, a whole heap of stuff. Now, if I go back to the website, it would appear that everything that's available once you click on the link is kind of in here. So let's go ahead and pull out some of the key values that we might be interested in. Okay, before we go too deep into each of these, let's just take a copy of this little guy here, and we'll leave this on the screen so we can always refer back to it. Now, what we're going to do is we are going to go to each of them and just get a feel for what they're all about. So let's start with something like underscore ID, okay? Underscore ID has an ID. I imagine that's let's think about this for a second. That's probably the unique ID of this particular listing. This might be useful later if we are going to go ahead and scrape all 1 million. If they've got unique IDs for each, we can use their unique ID. That's useful when we want to collect the delta. So we'll hold on to ID, and the way we'll do that is we will create a temporary dictionary just for each loop, and we'll call that something like data dict, and we'll start that off as empty. And then maybe what we'll do is we will add each of the elements we want. Okay, so we may not want absolutely everything out of this response, but in the interest of time, we'll just collect the most important ones. But then you, as the end user who may be running this, you can go ahead and follow the instructions and query everything. Cool. So we'll create the data dict, and then what we'll do is we will grab this listing ID. And so what we'll do is, for our purposes, we will go data dict, and we'll say ID, and we'll say that is equal to listing ID. So shift enter on that. Alrighty, and then if you look at our data dict down here, we now have an ID available to us. So we're off to a good start. Let's see what else we can get out of this query. So let's go ahead and we'll just enter down here, give ourselves a bit more space. So here is where we're collecting information. Here is where we're doing our testing. And this is just a little break to help us only select the first item in that list. So next we've got this _v. Let's see if that's going to be of any value. I'm not going to worry about that one. Employer seems interesting. So employer, print employer, doesn't appear to be anything. Is that the same ID? No, it's different. So employer is interesting actually. So it appears that it has the ID of the employer. So there's probably some data out there that tells us about the employer. So for example, there's one here called employer, but let's not get too ahead of ourselves. These underscore ones seem to be sort of a little bit interesting. So nothing in offices. Look at roles. Okay, roles appears to have some sort of ID again. And look, you can choose to collect these or not. Underscore tags. This appears to be the ID version of all of this data. Now let's have a look at created at. Let's have a look at created at. Beautiful. Now this is in a really acceptable time format. It's ISO time, so you got the T there and you got the Z for Zulu, which is basically UTC. What we want to do with this is we want to hold on to that. It's called created at, so very similar to before. We'll just add that into our data dictionary. So what we're doing is going created underscore at, okay. And this might help us later when we're trying to figure out the delta. So let's imagine we've scraped all 1 million, and a couple of days later, we only want to scrape those that were created at in the last couple of days. So let's grab the created at, which is made up of this one. Shift enter on that. Everything looks the same, but what you'll find is now in our data dictionary that we've created, we have an ID and we have the created at. So you can sort of see where this is going. We're going to go ahead and we're going to figure out all the different keys that we want to collect. We'll build up our own version of the data, and then we can go ahead and scrape every single page. So let's keep going through these. Now, you're kind of getting the gist of it. So what I might do is I might just quickly do all this, and we'll do some video magic and speed up the tape. Okay, so let's do that now. And we're back. So I've gone ahead and selected a number of key value pairs that I think would be interesting to collect. Now there is a handful here that we do need some further cleaning. I thought we can do that together. So the first one is places. So I'm not entirely sure how important things like address, longitude and latitude is, and formatted address. But what we can do is we can go ahead and have a look at the places. Alrighty. Let's run that one. Let's give ourselves a bit of a cleanup here. So we might just turn off this testing for now. Oops. Make sure you put the right thing in there. And we might just clear that for now as well. Cool. So Places looks like this, and it's got a couple of different things. It appears that it is coming from Google Places. Now, it's got the address, which in this case is just that. So we might go, what we might collect here just out of interest is place name, place address, longitude and latitude in case we want to put it on a map, and maybe the country as well. So to do that, all we need to do is now, first thing I'm noticing, places is a list, so there might be multiple places. In the interest of time, we are just going to grab the first place, but if you are building this for an ongoing sort of scraper, you might want to then see is there examples of multiple places, and do I want to collect all of them? So what do we agree on? We said we're going to get the place name. Let's just quickly make a note of this. So we're going to grab name. We are going to grab address. We are going to get the country, and we're going to get the longitude and latitude, which I might just quickly point out that it is point, and it's coordinates here. And long lat is stored like that. We could probably get away with breaking that out. I've assumed that this is longitude and latitude. If I'm wrong, I'll just swap them around. Nothing too serious. So let's kick things off. So what we've got is we've got places, and we're after places name. So to do that, we are just going to go ahead and, as we said before, pick the first item in the list and then select the name. So shift enter on that, and we've now got the place's name. Now the next thing we want is address. So it's going to be a very similar exercise. Okay. Selecting the address. Now that we've done that, we can see here we have the address. In this case, it's not too much to worry about. Same with country. So country is this one here. We can just go ahead and shift enter on that. And finally, we want to get the longitude and latitude. So We got places we want to get to point. Okay, once we're at point, we definitely want to get to coordinates. Alrighty, and we've got what I'm assuming to be lon and lat. So that's one of them. And then the other one is, because it is a list, we just select the second item, which is that one there. Now, there will be examples where that information isn't available. And if we did try to run this as is, it will go ahead and most likely fail. So one way around that is we can do a whole series of try and except, which is you try the command. If it fails, there's an exception and something else can run, or we can just pass right through. For now, we're going to leave it as is, but as we start to encounter these errors through testing, we can go back and clean that up. So where to from here? So what we're going to do is we are going to go ahead and replace the places. Okay, give ourselves some space. We are going to replace that with our data dictionary. And we are just going to go ahead, and let me just quickly paste all this in. We are going to say, okay, where are we? So we're going to go place name, place address, that easy, whoops, place country, place lon, and it could be wrong, we'll change that later, it's fine, place lat. Alrighty, let me clean up these equals. Okay, now that we've cleaned up those equals, let's go ahead and have a look at what else we're working with. So shift enter on that. What we now have available to us is in our data dictionary. You'll notice now, and let me just make sure we get rid of places because that is no longer required. Shift enter, shift enter. We now have a very clean key value pairs. We've got the ID, we've got all these really nice key value pairs. Original location, still a list, we can tweak that later, but the one I want to point out is the one we've just done, which is these places. So place name, address, country, longitude and latitude, which again might be mixed up. Cool. So where to from here? We now have to clean up a couple more: employer, tags and roles. I might leave that as homework for the commenters. So let me go ahead and just take those out for now. It's the exact same exercise we've done for places. So once you know one, you can probably do the others. So shift enter. And what we're left with is this really nice key value pairs, which looks like this. So you're probably wondering, hey, this is really cool, really awesome. You're a great guy. Good work. But where to from here? Now we have got 30 listings within our results. So what we're going to do is we are going to create an empty list. If you've seen my earlier episodes, I always like to call it master list, and it's just an empty list. And I can prove that by saying, show me master list. Okay, master list is completely, we don't need them, completely empty. Now, what I'm going to do from here is every time I loop through, okay, so every time I say, hey, for listing in JSON response results, I'm creating a blank data dictionary, okay, and then what I want to do is I want to say something like, hey, I've got a master list, okay, and I want to append that with the data dictionary. Okay, shift enter on that, shift enter, and we now have one entry into our master list. And the reason why we've only got one is because we have this break. Shift enter now, shift enter again, and straight away what you'll notice is, we got an error. Okay, original post date. So this is what I spoke about before. There will be instances where we do encounter errors. So there's a couple of ways to overcome this. One of those ways is through a try and accept, and another way is through the get keyword. So what I might do for all of these ones, I might use the get keyword, and I'll show you how that works. What that looks like now is we want to get the listing ID. So we say .get, open and close bracket, and we'll get the listing ID, which looks like that. Okay. So what that does is we're still going to get the same error from this original post date. So let's find that and use the get on that one as an example. So what we're going to say is again listing .get. Okay. And we've got the original post date. Now let's have a look at that. So shift enter on that. And we've got to keep going through these. We've also got the original job category. Okay. I'm going to do a little speed up one more time, and I'm going to just do a .get on all of these. One moment, please. Okay, pause there for a moment. So what we've done is we've done the .get on all of these, nice and easy. So this will just say, hey, try to get the ID, but if you don't get the ID, just return no value. And we will tweak this in a moment to return something a bit cleaner for our example. Now, what we've also got is the try and accept. Okay, so we can try to get the place name, but if you can't get the place name, that's okay. let's just make it equal a blank string. Or the other option here, obviously, well, not obvious if you're not used to using Python, is the none command, okay? Alrighty, so what we'll do is we will go ahead and just replace that with a blank string. And again, let's do another video montage to speed that up nice and quick. Okay, and we're back, and that's gone ahead and run. So just to take you through that, we're using the .get method to select the item, and if that item doesn't exist, don't worry about it, just return nothing. And in here we're using the try and accept method, and you'll notice here this try and accept, I've actually included both the longitude and latitude, and the reason for that is if one isn't available, it's not going to be much use to me. I kind of need both. I could have quite easily have done the try and accept across the entire block here, but one risk we run doing that is if the address is available but not the name, we kind of get nothing. So this way it just says, hey, let's try and get the place name, but if it errors out like it doesn't exist, it's blank, let's go ahead and just make it blank, so we've actually got that key value pair still available to us. So what that means is now when we look at our master list, we now have a list of dictionaries, which is our 30 listings, which is in the format that we want to be able to download and analyze further. So where to from here? So something I like to do is import pandas as PD. Okay, if you've seen my previous videos, you know pandas is an amazing data analytics, data science package. Now I'm going to create a data frame, we'll just call it df for now, not a great variable name. And the df or data frame is equal to pd.data frame, and we can just pass in our master list. Okay, shift enter on that, and what we find is we now have a very clean tabular sort of report that we can quite easily put into Excel. And as we scroll along, we can sort of see all the data, and you'll see examples of none where it's there's no data available. What I might do just quickly is in our get commands, I might actually go ahead and do a comma and then pass in just an empty string. And now the reason I'm doing that is I don't want the word none coming through my data. I just want it's just an empty string. Okay, just no real data. It's still a string, but it's completely empty. So let's apply that now. Shift enter one more time, shift enter, shift enter, shift enter, and you'll now notice we no longer have none in there. We actually just have no data. So an empty string, if you will. Cool, so let's just have a look at this data, make sure we've got it right. First thing I'm noticing, original locations appears to be a list, and I think what we'll do there is with original locations, we will just pick the first one in the list. So what do we got here? Original locations. Now we are using a get, okay, and what we'll do is we'll kind of combine the two. That will probably fail. Let's have a look. Okay, if it's successful, we are picking the first one. No, that will work. So original locations, looking good. So I'm now just scrolling through, inspecting the data. Now everything looks really nice actually. We've got longitude and latitude, we've got all different countries here, we've got all of the sort of URLs, but the next challenge we have is how do we go ahead and systematically download each of those pages and sort of package this data up and save it to file. So let's have a think about how we might do that. If we scroll to the top, what we know about this query is it does actually use a parameter called page. So if I go ahead and change the page, maybe from 3 to maybe 4, shift enter on that, it's going off and requesting that data. That's finished now. Shift enter, shift enter, shift enter, and we'll just go down to our new data frame. And what we'll notice here is this is now a new set of data for that particular page. So the approach in my mind seems pretty straightforward. What we'll do is we'll continually go through each of those pages pretty much until we get to the end. For the initial sort of web scraping, we'll just try to hit it 30,000 times to get the bulk of the data. And then the ongoing scraping, if you wanted this data available to you on a regular basis, we would probably go ahead and look at maybe having a look at the most recent posting date, or hey, I know that there's 100 posts per day, so I only really need to go back a page or two or something like that. So let's go ahead and do a quick example of how we might be able to scrape a number of pages. So first thing we're going to do is we are going to package this up and we will, let's have a look. So we're going to create a function. So we're going to define a function called maybe get listings, get jobs, get listings. And that's going to have a variable passed into it called page. Okay, and you're probably picking up where I'm going with this. So get listings is as easy as passing in a variable called page, and then making sure that the page variable is passed into the parameters. And just in case it's a bit picky, we'll make sure that's cast as a string, okay? And then the final thing we want to do is we know that this is a response of type JSON. So what we'll do is as part of that, we will just return the JSON response, okay? So shift enter on that. We now have packaged up that code and we've got something called get listing. So if I create just a variable here called listing and go equals to that, what we get is an error because I haven't put the page in, okay? I'm after page 10, shift enter on that. It's running now, it's getting page 10 for us, and we can prove that by having a look at this listing, shift enter on that, and straight away you can see here that it's gone ahead and pulled all that data. So what we've done is we've packaged up that small amount of code into a function that we just pass a page into, and then we can actually go ahead to our next step. So from here, our next step feels like we sort of want to be able to process the data. In fact, you know, I'm almost thinking, why don't we just put the whole thing into the same function? I'm not envisioning a world where I want to get the page and then do something different with the data. So to do that, it's as simple as taking all of this work we've done here and literally just plopping it into the function. Now we do need to keep an eye on our indentation. So what we'll do is we will just tab that in, okay? So the for loop is here, everything in the for loop is indented a little bit, and then the return JSON response is no longer required. We want a response of, we want to return the master list, okay? So let's have a look at that one more time. So shift enter to put that into memory. And what we might say is listing is equal to get page, and pick another page, page 20. All right, shift enter on that. And now when we look at listing, okay, we are now getting this very clean sort of set of data back. Now we might even want to take this a step further, depending on how far you want to go with your function. But what we could potentially do is go ahead and create the data frame inside that function and then return the data frame. So shift enter on that. And now this time when I ask for page 20, I'm not going to get back a list of dictionaries. I'm actually going to get back a data frame. Now, one of the benefits of that, I can quite easily run a toCSV, okay? And toCSV, we can just call this, you know, page underscore 20.csv, and we don't want the index, which is the column on the left, which is index equals false, okay? Shift enter on that, and that's actually written the CSV file to our disk. So let me go ahead and show you that. Okay, so that's opened up now, and as you can see, we now have this really well-structured data. We now have that ID we had, you know, the created at, all of those sort of variables. And if I just go ahead and expand this out a little bit, you can see that this is very well structured data. Where available, the data is flowing in really nicely. They've even got, in many cases, the longitude and latitude, which is, you know, really nice data. So now that we're at the point that we're able to collect this data and quite easily output it to CSV, it also means we can probably quite easily put it into a small database or something like that. Now, this particular question from the comments is getting a little bit long, so I'm going to pause there. I feel like I've given you enough sort of instructions on how to go off and collect that information, okay? And what we might do is we might return to this one at a later date and have a go at going ahead and iterating through each of those pages and saving it into an SQLite database. If that's something that is of interest to you, please drop me a comment below. As always, a huge thank you to everybody who's subscribed. I've now hit over 500, which is, for me, unbelievable. 500 people actually want to watch these videos and learn some Python along the way. So yeah, huge thank you. Thank you for taking the time to watch this video today, and yeah, have a good day.